Hello friends, good morning to all. This is Prasad Alex from Seed Chemistry Point. Today we are going to discuss a question based on Bohr model of atom. This is a type of question we usually encounter in JEE main, JEE advanced and even in JAM examination. Right, we move on to the question. In which of the following species the wave number of transition from n equals 9 to n equals 3 correspond to the second line of Lyman series of hydrogen atom? The choices are helium atom, He plus ion, lithium plus ion and lithium 2 plus ion. Right, we have to find out the choice. Of course, this has to be solved based on the Bohr equation for energy or the more convenient formula, the Rydberg formula. So we can take the Rydberg formula. It is given as nu bar equals RH into Z square into 1 by N1 square minus 1 by N2 square. So N2 is the higher energy level, quantum number of higher energy level, N1 is the quantum number of the lower energy level, among which the transition takes place. Okay, fine. Right, here we have to consider two transitions in two different species. One species we know, it is hydrogen atom, simple hydrogen atom. The other species we have to find out. Before we go into the equation, we have to know this equation is applicable only to one electron systems. Among the choices, helium atom is a 2 electron system and lithium singly positive ion is also a 2 electron system. So that two choices can be discarded. Now our choice is between He plus ion and Li2 plus ion. So you have a 50-50 chance if you make a blind guess. Right. But we need not do a blind guess. We can do the problem based on the Rydberg formula. We can solve it easily. Right. So you take Lyman series, second line of Lyman series. First line of Lyman series is the transition from second orbit to the first orbit, or the second energy level to the first energy level. And the second line is the transition from the third energy level to the first energy level. Right? So we have the quantum numbers n equals 1 and n is equal to 3. n1 equals 1 and n2 equals 3. We put that values here. And for hydrogen atom we know Z is 1. Atomic number is 1. So it is RH into 1 square into 1 by 1 square minus 1 by 3 square. And this we have to equate with the other species. For the other species, Z is not known. No problem. We have to find out Z. So RH into Z square. But the initial and final energy levels, quantum numbers are given here. We put the values here. 1 by 3 square minus 1 by 9 square. Okay. These two has to be equated. Now we can take this 1 by 3 square outside the parenthesis. What we get is RH into Z square divided by 3 square into 1 by 1 square minus 1 by 3 square. Now we can examine the two equations and we can see that 1 square is equal to Z square, 1 square, that is the Z square value here. So 1 square should be equal to Z square by 3 square. So that means Z should be equal to 3. Right? Z is equal to 3, that means the answer is lithium ion. That is a 1 electron system. Its atomic number is 3. So we have found out the species in which the transition from n equals 9 to n equals 3 correspond to the second line of Lyman series. Right? So our answer is reached. To reach this answer, we require the Rydberg formula. We want to substitute all the parameters there. Then we have to do some arithmetic manipulations. Then only we can reach the Z value. So it requires some time. It requires some diligence. It requires some application of mind. Right? You can do it. Any student can do it if your mind is applied. But we can have a shorter method also. We did not go through all these formula. We can see that energy level of any one electron species will correspond to hydrogen atom, what we have to do is that the quantum number is simply multiplied by the atomic number. So n equals 1 in hydrogen atom will correspond to n equals 3 in lithium 2 plus ion. N equals 3 in hydrogen atom will correspond to n equals 9, 3 multiplied by 3 of lithium atom. So what we have to do is that we find the ratio, and that ratio will be the atomic number of the species considered. Similarly, we can have He plus ions. In He plus ion, you can see that this line will correspond to n equal to 2 to n equals 4. Right? That's how we can solve it. If you know the atomic number, simply multiply the quantum numbers, you get a corresponding transition. Right? We have to know the second line of Lyman series, which are the quantum numbers involved. Then only we can do it. So if in a question it is asked that the third line of Balmer series, what we have to do is that first line of Balmer series is n equal to 3 to n equal to 2 transition. Second line means n is equal to 4 to n equal to 2. Similarly, third line of Balmer series n equal to 5 to n equals 2. In that way, we can find the quantum number of any transition given, and we can do the problem easily by simply multiplying by the atomic number. We can find the corresponding transitions in any of one electron systems. Thank you. I hope that you have followed it. Meet you again.